Welcome back. In this video, we are going to solve a structural design problem that involves a cantilever beam design using load and resistance factor design method based on eStructural Design Tao found on the App Store. Design a reinforced concrete cantilever beam using load and resistance factor design with span of 8 feet, assumed size of 10 inches by 20 inches. The beam carries a uniform dead load of 600 pounds per foot and uniform live load of 200 pounds per foot, and a concentrated dead load of 9,000 pounds and concentrated live load of 3,000 pounds at the edge of beam. Design criteria as follows: strength of concrete 4,000 psi, main bars 1 inch diameter, grade 40, stirrup bars 3/8 inch diameter, grade 33. The beam carries a uniform dead load of 600 pounds per foot and uniform live load of 200 pounds per foot. The beam self-weight is 209 pounds per foot for a factored uniform load of 1,290.8 pounds per foot. The beam also carries a concentrated dead load of 9,000 pounds and concentrated live load of 3,000 pounds at the edge of beam for a factored concentrated load of 15,600 pounds. Enumerate input parameters required. Name of beam CB6, type of support cantilever, width of beam 10 inches, depth of beam 20 inches, length of beam 8 feet, main bars 1 inch diameter at grade 40, stirrup bars 3/8 inch diameter at grade 33, strength of concrete 4,000 psi, factored uniform load is 1,290.8 pounds per foot, and factored concentrated load is 15,600 pounds. Given factored uniform load equals 1,290.8 pounds per foot, factored concentrated load equals 15,600 pounds, L equals 8 feet, the maximum moment from uniform load is 495,667.2 inch-pounds. The maximum moment from concentrated load is 1,497,600 inch-pounds, for a total maximum design moment of 1,993,267.2 inch-pounds. The raw max from the given design criteria is 0.03712. Then the maximum concrete beam design ratio Rn max equals 1,159.62 psi, followed by maximum moment from given section Mu max equals 3,196,202.62 inch-pounds, which is greater than the maximum design moment Mu. Given Mu equals 1,993,267.2 inch-pounds, resistance factor equals 0.9, B equals 10 inches, and D equals 17.5 inches. The beam design ratio Rn equals 723.18 psi, and reinforcement ratio ρ equals 0.02057. Given ρ equals 0.02057, B equals 10 inches, and D equals 17.5 inches, the area of steel for tension bars is 3.59975 square inches, and the number of bars for 1 inch diameter is 5. The number of compression bars is 2. The shear force for dead load is 15,472 pounds. The shear force for live load is 4,600 pounds, for a maximum shear force of 25,926.4 pounds. The nominal shear force is 34,568.53 pounds, greater than 22,135.94 pounds concrete capacity. The shear force capacity of stirrup is 12,432.59 pounds, less than 88,543.77 pounds maximum stirrup capacity. Maximum spacing is 6 inches. The shear force at face of support is 9,324.45 pounds, and initial spacing at 13.63 inches. The stirrup spacing are as follows: 1 at 2 inches, 1 at 4 inches, rest at 6 inches. For 1 inch diameter main bars, use ½ inch diameter stiffener bars. Design recommendation as follows: FC prime equals 4,000 psi, Fy equals 40,000 psi, Beam size is 10 inches by 20 inches by 8 feet. Main bars of grade 40. At support, top bars 5 pieces 1 inch diameter bar. Stiffener bars 2 pieces half inch diameter bar. Bottom bars 2 pieces 1 inch diameter bar. Stirrup 2 legs of grade 33. 3/8 inch diameter bar spacing. 1 at 2 inches. 1 at 4 inches. Rest at 6 inches. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.